All right, guys. Next thing we're going to cover is systems of inequalities. Okay, so same deal, except it's a greater than or less than instead of an equal to. There is no elimination or substitution. You can really only do this by graphing because the solution is a solution set. It's a whole group of points, and we have to shade part of the graph that solution is part that the solution set goes over. Okay, so we want them to be in y equals form. These already are. Okay, if they're not in y equals form, we've done enough examples of y'all seeing that, so you know what to do if it's not in y equals form. All right, so we plot our y-intercept. So we've got -3, and then we do our rise over run. So it's up 2 over 1. Do that a couple times. Okay, and then make sure you're looking at the inequality to tell you if it's a dotted line or a solid line. So equal to means it's a solid line through there. A little curvy, but that'll do. All right, and then this one we have a +2 and then -1 over 1. All right, and this is not an equal to, so this one's going to be a dotted line through those points. All right, and then we have to shade. So this first one is greater than. So remember, if you like tilt it to the right because it's slanting right, then to make that line flat, this would be the greater than part. Okay, and then the second one is less than. So this line on the less than is beneath it, so that's this part. And I bet you can guess where the solutions are located. It's where the two shadings overlap. So you want to color that one in extra dark. Let me and whoever else is looking at your stuff know that that's where the solutions are located. Okay, all the inequality rules apply. So if there is a solid line that is touching this section, then those points count too. So this point right here, this point right here, all of these points count. Okay, but if it's a dotted line, they do not count. So all the points on this dotted line, even though it's touching the double shaded section, those points do not count as a solution. Okay, so if you're doing a multiple choice question, they're like, which of these is not a solution? And they give you a point on this line over here, then that's the one. Okay, why don't y'all try to graph this one on your own and see what you come up with. Alright, so this one we have to +1, then we have a -1, 2, 3, 1, 2, 3, 4. Okay, do up 3 and left 4. It's an equal to, so it's going to be a solid line. Alright, the next one's -2, and it's got that same slope, so these lines are going to be parallel. And it's also a solid line. Now, we learned with the equations that parallel lines were automatically no solution. That's not true with inequalities. Depending on which way these inequalities face, we could get an overlap. So this first one, the one with the +1, is greater than +1. So greater than would be this section here. And the second one is less than or equal to -2, which would be down here. So this one is actually also, like its equation counterpart, no solution. There's no parts of the shadings that overlap. But what if they had changed? All right, so let's erase what we have here. All right, nope, not gonna do that. All right, let's see, 1 second here. All right, so let's get rid of all these shadings. Get rid of these down here. Alright, so what if these equations had changed to y is less than or equal to on this one, and y is greater than or equal to on this one? Okay, so same two lines, but now I'm going to shade below the +1. That's this section here. Everything below. And above the -2 one. So that's this section here. Everything above. Well, you see that even though they are parallel, there is still an overlapping section right there in the middle. So just because it's parallel doesn't automatically mean it's no solution for inequalities. You could still have an overlapping region in the middle. Okay, or they could both go the same direction and you could have an overlapping region out here or down here as well. So just pay attention to which way the signs are going. Make sure you shade the correct section. And then if they overlap, that's the solution set. If they don't overlap, like our first example, then it's no solution. Okay, and that's all. That's the only way to really describe the solution set. You can't write it out in words or set notation or anything. So it's just the graph. So you have to be able to graph these if you want to be able to describe the solution set. All right, let's do a word problem. Rebecca wants to bake cookies and cupcakes for a bake sale. She can bake 15 cookies at a time and 12 cupcakes at a time. She needs to make at least 120 baked goods, but no more than 360 baked goods. And she wants to have at least 3 times as many cookies as cupcakes. So what combination of batches of each could Rebecca make? All right, so this one gives us 2 variables, cookies and cupcakes. So you'll use x and y because we're going to be graphing. So cookies are x and cupcakes are y. So she can cook 15 cookies at a time, so 15x plus 12 cupcakes at a time. It needs to be at least, there's one of your key words, at least is greater than or equal to 120. But it also has to be no more than, there's another key word. So I'm going to make the same equation, 15x plus 12y less than or equal to 360. Okay, but then there's actually a third equation on this one. Now 2 is the minimum, but you could have more as well. So this one has 3 more. She wants to have at least 3 times as many cookies as cupcakes. Okay, she wants to have more cookies than cupcakes. So cookies at least greater than or equal to 3 times the number of cupcakes. 3 times as many cookies as cupcakes. Alright, so x is greater than or equal to 3y. Alright, so if we want to graph all these, we need to get them all to be in y equals slope-intercept form. So I'm going to subtract 15x on both of these. So I get 12y is greater than or equal to negative 15x plus 120. And this one I get 12y is less than or equal to negative 15x plus 360. And then this one I want to divide by 3. So I get y is less than or equal to 1/3 x. Okay, there's always that 1 in front, so I'm just pulling that off, making it a 1/3 so I can see my slope. I also flipped it around, see y is less than, so you have to make sure to flip that sign if you move the y to the other side. Alright, on this one we're going to divide everything by 12. Same thing with the next equation. So I end up with that, and then y is greater than or equal to negative 5/4 x plus 10. And then this one is y is less than or equal to negative 5/4 x plus 30. 36 divided by 12 is 3, and then add a 0 on the end for the 360. Alright, so we're going to go graph all 3 of these. Alright, I'm going to look at my biggest y-intercept, which is 30. And so I'm going to need to scale this because I don't have 30 spaces here. So let's see, 2, 4, 6, 8, 10, 12. That's not going to be enough. So let's do 3s. Alright, 3, 6, 9, 12, 15, 18, 21, 24, 27. There's 30. So one of my y-intercepts is going to be there at 30. Alright, one of them is going to be down here at 10. Which is right about there. The other one's going to be at 0. Alright, if we go by 3s as well on here, that'll make our life so much easier. So I'm going to go by 3s here as well. Okay, 30 is probably enough to mark it out. I really don't need the rest of this graph. Everything's going to be in the positive quadrant. Alright, so I could have really drawn it out a little bit bigger than this, but this will do for our purposes. And the reason I want the same scale is because we can just count. So I know the slope is negative 5/4. 1, 2, 3, 4, 5. 1, 2, 3, 4, like that. Alright, and that'll just make our life so much easier. Alright, and this one we have negative 1, 2, 3, 4, 5. 1, 2, 3, 4. Now my graph isn't going to be able to go all the way down there, but something like that. And then this one goes 1, 1, 2, 3. 1, 1, 2, 3. And it's going to go up like that. Alright, so this wants you to know what are the combination of batches. So I want less than the 1/3, so that's going to be down here. I want greater than the plus 10. The plus 10 was this one right here. So greater than that would be this way. And then I want less than the plus 30, which would be this way. So it's going to be this little section right here. So any point in that section would be a combination of the different batches that we could use. Alright, last thing is finding the vertices of an enclosed figure. Okay, so we need to graph all of these. So I'm going to get them in slope-intercept form. So this is negative y greater than or equal to negative 2x minus 1. Need to divide everything by negative 1. And don't forget to flip your sign. Y is less than or equal to positive 2x plus 1. Alright, this one, all I have to do is subtract x, and I get y is less than or equal to negative x plus 4. And this one I need to subtract x. That gives me 4y is greater than or equal to negative x plus 4. I'm going to divide by 4. And y is greater than or equal to negative 1/4 x. There's always that 1 in front, and you can just pull it off like that, plus 1. Okay, so let's graph all of these real quick. We've got the plus 1 and the slope of 2, rise over run. Okay, it's equal to, so it's a solid line, and it's going to shade less than, which is down here. Okay, again, I'm not going to go crazy on my shading yet because there's 3 of them. Alright, the next one is plus 4. So that's 1, 2, 3, 4, and it's got a negative 1 over 1 slope. It's also a solid line because it's an equal to, and it's less than, so it's going to shade down here. So far we're kind of in this section right here. Let's see what this one gives us. Alright, we're at plus 1 again, but now it's a negative 1/4. 1, 1, 2, 3, 4. Alright, so it looks like it's going to cross through there. Okay, it should intersect both of these. And because it told us it's going to be a triangle. And there we go, and it shades above, which is this section here. So they're all 3 overlapping right here. Alright, and wants us to know the vertices of these triangles. So I've got one right here. That's pretty simple. That's 0, 1. We've got one over here, which is 1, 2, 3, 4, 0. Alright, and then I've got one right there. Okay, which looks like it's at 1, 1, 2, 3. 1, 3. Okay, you want to double check these and make sure they should solve the 2 equations that they match up with. So like the 1, 3, that's the one I'm most unsure about. It goes with the plus 4 one. So if I plug in 1 and 3, those should match up. Okay, 3 is less than or equal to negative 1 plus 4. Well, negative 1 plus 4 is 3, so that looks good. And then it also matches up with the positive sloping one, which is the 2x. So that's 3 less than or equal to 2 times 1 plus 1. That's 2 plus 1, so that's 3 less than or equal to 3, so it matches up. So anytime you're figuring out these points, you can always plug them back in and make sure they solve the equations you were actually graphing.